Hey guys, welcome to Conceptual Geometry, Lesson 5.2, Slope. What is slope? Slope is the steepness of a line, or the ratio of rise to run. So what are you talking about, the ratio of rise to run? Well, let's say I've got these 2 points here, A and B. The rise is the amount you have to go vertically, so that would be your rise, and the run is the amount you have to go horizontally, so that would be the run. The symbol for slope, and nobody knows why this is the symbol, is a lowercase m. Don't ask me why. All right, so now let's talk about some general slope characteristics, starting with a positive slope. A slope is positive if it goes uphill. Okay, so any slope as it goes left to right, if it goes uphill, it's positive. So obviously then you can probably infer that a negative slope would go downhill, left to right. A zero slope is a horizontal line. So if you think of skiing, think of it as being flat or perfectly horizontal. A no slope, or also referred to as undefined, which is how I usually refer to it, would be a vertical line. So that would be, think of it as a cliff or vertical. Okay, so let's find some slopes. First example, find the slope between C, which is 1, 1. Let's plot that point. There's C. And D, 3, 4. There's D. So I want to find the slope of that segment. So what I'd like you to do is create a right triangle. And what that does is it tells you what the rise is and what the run is. The rise is the vertical piece of this triangle. So count the blocks. 1, 2, 3. The rise is 3. The run is the horizontal piece. That is 2. So your slope here would simply be 3 over 2, which means up 3, right 2. And you could just keep making steps. Okay, so if I were to just keep going, I just keep making steps. 3, 2, 3, 2, and all of those would be on this line. Okay, next. Find the slope between C, which is 2, negative 3. So there's point C. And D, which is 5, 1. There's D. So once again, it's kind of a simple process. We're going to make a right triangle. Count the rise, number of blocks, 1, 2, 3, 4. And count the run, 1, 2, 3. So in this case, my slope is rise 4 over run 3. Both of these, you notice, have a positive slope because they're going uphill as you go left to right. Now, like midpoint, we're not going to graph these coordinates every single time and count the slope. So we want to come up with a formula. The formula for slope is m equals y2 minus y1 over x2 minus x1. Now you might wonder, why is it y minus y over x minus x? Because if you remember, it's rise over run. What determines the rise is the difference in the y values. So those that maybe take chemistry, remember from science in middle school, delta means the difference. So you can think of slope as delta y over delta x. All right, well, let's start crunching some numbers here and finding the slope using that formula. And if you notice, I don't write this formula out every time, and it's not necessary that you do so. What is important is that you understand that you are substituting in numbers here, and that slope is always subtraction. There's going to be negative numbers thrown in here, and we'll deal with that in a second, but it's y minus y over x minus x. And you'll notice I substitute directly into that formula. So for part A, my slope equals, the y values are 4 and 1. Okay, so that's 4 minus 1. The x values are 3 and 2. So that would go in the denominator, 3 minus 2. Well, this first one's pretty easy. 4 minus 1 is 3. 3 minus 2 is 1. I know usually you guys like to clean this up and just write 3, which is acceptable. But since slope is rise over run, I always like to see a fraction here when it comes to slope, because I know how much I need to go up and how much I need to go over. All right, next example. Slope equals, what are my y values? 2 and 0. So that'd be 2 minus 0. What are the x's? 2 and negative 3. So this is where it becomes tricky. It's always subtraction. So it's 2 minus a minus 3. The numerator here is simple. 2 minus 0 is 2. But please watch out for this. I recommend you put this directly into the calculator, or if you're very good with adding, subtracting negatives, you know that those two would end up canceling out. So this becomes 2 plus 3. So that denominator is actually 5. All right, letter C. Slope equals y minus y. So we're going to see this often with these negatives. That would be 6 minus negative 4 over negative 1 minus negative 3. So this is about as confusing as it gets. These two negatives here cancel. So this ends up being 6 plus 4. That's 10. And then down here, these cancel. So it ends up being a negative 1 plus 3, which is 2. Now, I'm totally fine if you leave it like this. Some of you guys probably recognize, oh, I could simplify that, divide them both by 2, and I get 5 over 1. Also, totally fine. If I just ask you to find the slope, you don't have to compare it to anything else, and it does not say simplest form, I'm totally fine with you guys leaving it 10 over 2. You'll see later on in the lesson, though, there will be a case where you must simplify. But for this type of question, it's not necessary. All right, so in this group, I'd like you to pause the video, and I want you to try these on your own. Try these 3 on your own, then you can resume the video and compare your answers, all right? Because we're doing the exact same thing we just did on example 3. All right, so for A, I want to find the slope. I'm going to take y minus y, so 5 minus 5. X minus x is 2 minus 3. Now notice here you get 0 over negative 1. This is the one case, actually there's 2 cases, one of the 2 cases where I do not want you to leave it as a fraction. Because if you remember in the beginning, we've got 2 types of slope. One of them is 0, which indicates a horizontal line. The other one is undefined, which indicates a vertical line. So what we have to remember, when 0 is on top, that slope is 0. So in this case, I would not accept this for full credit. You have to go ahead and tell me it is 0. All right, next one. Slope equals y minus y. So we have to watch out for those negatives. Negative 1 minus and negative 4. Notice I substitute directly into the formula. Don't try and take any shortcuts, please. Next, negative 5 minus negative 7. So here, these 2 negatives cancel out. I have a negative 1 plus 4. That gives me 3. In the denominator, these 2 negatives cancel out, and I have a negative 5 plus 7. That's 2. There is your slope. And my last one. Y minus y. 1 minus 0. Denominator 5 minus 5. So notice what you get here. You get 1 over 0. This is not the same as that. So I'm going to go back to the beginning here. 0 is equal to a fraction. 0 over some number. Undefined is equal to a fraction, some number divided by 0. Just remember you can't divide by 0. So when you get this, you can't leave it 1 over 0. You have to go ahead and tell me that is undefined. And UND is shorthand for undefined, and that's how I usually write this. You could write no slope, but to me, no slope is a little confusing because you might confuse no slope with 0 slope. 0 is nothing, no slope. And it's not true. It doesn't work that way with slope. So I just prefer undefined. All right, our next task. Collinear points. Points are collinear if, first of all, they lie on the same line. How do we know if all the points lie on the same line? The slope is the same between all points. That's how we're going to determine if points are collinear when we can't see their picture. All right, let's try a couple examples. Find the slopes of JH and HI. Write a conclusion about your findings. Okay, so we're going to find slope. We use lowercase m and JH. So this indicates, and this is the first time we're seeing this notation, that I'm finding the slope of segment JH. Remember, it's y minus y, so y minus y, negative 2 minus 2 over x minus x, so negative 5 minus negative 2. All right, so my numerator, negative 2 minus 2 is negative 4. My denominator, remember these cancel out. Those two negatives cancel out as a negative 5 plus 2, which is negative 3. Now, this is the first time we're seeing this today. I cannot leave two negatives in a fraction. Remember, a negative divided by negative is positive. So in a fraction, those two cancel out, and I do want to write this as 4/3. All right, so now let's find the slope of HI. So now I'm using these two, starting with y minus y, 2 minus 10, over x minus x, negative 2 minus 4. So 2 minus 10 is a negative 8. Negative 2 minus 4 is negative 6. So I do need to simplify this. Two things I need to do, cancel those, and then divide both of those by 2, 4/3. So what we notice here is that the slopes are the same, those are equal, between all of these points. Write a conclusion about your findings. So we are gearing up towards proofs. This would be one step in a proof. So I'm going to say here, collinear, because the slopes are equal. And yeah, we have to write all of that out. That would be a complete problem right there. Okay, last example. Determine if the points A, B, and C are collinear. Explain your reasoning. So this is the same setup as up above. They just didn't tell us what to find the slope of. But it's pretty straightforward. It's going to look like this with different letters. That's all. Okay, so let's try this. I want to find the slope of AB. So I'm using these 2 points, and let's start with y minus y. 4 minus 6 over 2 minus 6. So 4 minus 6 is negative 2. 2 minus 6 is negative 4. We'll cancel those negatives and simplify that fraction. That's 1/2. All right, so now I want to find the slope of those two, BC. All right, so the slope of BC, we'll start with y minus y, so that's 6 minus 8. And then x minus x, 6 minus 9. So 6 minus 8 is negative 2. 6 minus 9 is negative 3. Clean up those negatives. That's 2/3. So the slope between A and B is 1/2. The slope between B and C is 2/3. Those can't be on the same line, because if you kind of visualize what's happening, here's A, here's B, here's C. This slope is one thing, then that slope's another. So the line, the direction has to change, basically. So I would say not collinear because the slopes are not equal. So there's a case where they would not be collinear. All right, guys, that concludes Unit 5, Day 2 notes. Thanks a lot for watching. As usual, reach out if you have any questions. We'll see you in class soon.